Hi, welcome to chemistry. This first unit we're just going to talk about some of the basics with chemistry, which may be a review for some of you from biology. And the first thing we just need to discuss is what is chemistry itself. So the definition of chemistry is the study of the composition of matter and the changes that matter undergoes. Again, that was the study of the composition of matter and the changes that matter undergoes. This definition doesn't help you very much if you don't know what the word matter means. So next let's talk about what matter is. Matter is considered to be anything that has volume and mass. Anything that has volume and mass. And again, that definition doesn't mean anything to you if you don't know those two words. So let's just review volume versus mass. I know you probably have learned about it in other science classes, but just as a refresher, volume is anything that takes up space. So on top of the word volume in your notes, just put in parentheses space to remind yourself that volume is how much space something takes up. Mass is more of how much stuff is in that space. So mass is the amount of particles that you have. Most things in the room right now that you're looking at are considered to be matter, anything that takes up space and is made up of stuff. However, there are a few things in the room that exist but are not taking up any space. And the first thing students usually say when I ask them what is something in the room that's existing but not taking up space, they usually tell me air. Air actually is considered to be matter because it takes up space even though it doesn't seem like it does. And an example of that would be when you blow up a balloon. The balloon is contained by, has air inside of it, which is being contained by the balloon. And that air is actually taking up space. And it's also made up of particles. You have oxygen particles, nitrogen particles, carbon dioxide particles, and those all do have some sort of mass. So even though air seems like it's made of nothing, it actually is something that's considered to be matter. Things that are not considered to be matter would be things like light. Light exists, you can see it, and you know it's there, however it doesn't take up any space. Same thing with heat, radio waves, and magnetic fields. So these are just some examples of things that exist in nature that do not take up any space, and they don't have any mass. The next thing we're going to talk about is the scientific method, which you probably have talked about in any science class that you've taken. However, the scientific method is not something that's set in stone. And in fact, when I was taking graduate school, they warned us not to teach the scientific method because it ingrains in students' heads that science is only done one particular way. And you have to keep in mind that a lot of science is done by accident, and it's done in a circular method. So you try something, it doesn't work, you try something different, you have to rearrange your procedure. So keep in mind that the scientific method is not set in stone. What it is just a systematic approach. So as you're starting to learn to become young scientists, this is going to be an approach that will help you figure out how to create an experiment that will test whatever you're trying to test. So it's a systematic approach for learning about the world. And there's several parts to this. The first part is just looking at your surroundings to figure out something that maybe doesn't make sense to you, and that's what a scientist would test, or something that is a problem and you want to fix. And so the first thing scientists are going to do is observe. They see something that doesn't make sense or something that is a problem, and they're going to gather background information about it. So making observations is your first step. The second step involves a word that you may not have heard before. It's a word that we really only use in the world of science, and that word is a hypothesis. So just to review from biology, a hypothesis is a suggested explanation for something that's happening. A lot of times you might hear the definition an educated guess, and I try not to use that definition because I don't like the word guess. Guess to me means just a random choice, and a hypothesis is much more informed than just a random choice. Once scientists have done all the background information, made the observations, formed their hypothesis, the next step is the fun part, and that's to actually perform the experiment. So you're going to actually do the experiment and test your hypothesis. When you do an experiment, it's important that you know how to set up the variables though. And in fact, in our first unit, we're going to do several experiments in class where you're going to have to create your own experiments. And in order to do that, you need to know how to set up your variables. So first, let's just write down the word variable, which is any factor that could change. Either you're changing it yourself or it's changing by itself as a response to whatever you're doing. A variable is a factor that may change. And there's three types of variables. There's the independent, the dependent, and the control variables. So let's use an example of a science experiment just to give you an idea of the differences between them. And in this example, we're going to say that we're going to test how fertilizer affects a plant's height. So the first thing you want to think of is what is the one thing you're going to control for each different trial, or the one thing that you're going to change for each different plant. And in this case, that would be your fertilizer. So we call that one the independent variable. Another word for it is manipulated variable. That's the one thing that you're going to change. Now notice that I have the word one in capital letters, and that's because it's really important that you only choose one variable to test. If you choose more than one variable, you can't decide what is being affected. If it's, say we choose sunlight and fertilizer, then the plant height could be because of the sunlight or the fertilizer. So we haven't proven anything. So it's really important just to choose one. Your dependent variable is the thing that's going to change based on what you do. So since we're changing the fertilizer, we're assuming or we're hoping that the plant height will change because of that. So the height of the plant is going to be dependent on the fertilizer. So we call that the dependent or responding variable. And this is the thing that you're going to measure during the experiment. You don't have any control over it. The one that you're controlling is the independent, but the dependent is the one that you're actually measuring. And the last one is all the other variables that you need to keep constant. So like I said, you only want to choose one independent variable. So as you do your experiment, you need to consider what you need to keep constant. For example, in this experiment, you need to keep the sunlight constant, and the amount of water, the type of soil, maybe the temperature of the room. All of those things should be held constant or the same for each trial, and that's so that they don't influence the results. And you have to keep in mind that control variables are the things you keep the same. There's also something called a control setup, and this is going to be a trial where you don't do anything to it. So if you're testing the fertilizer, you need to have one plant that doesn't have any fertilizer at all, and that's going to be used for comparison for the other experiments. So the control setup is the one that you don't actually do anything to. And I also want you to keep in mind that in the world of science, you tend to do multiple trials. So if you were a scientist or a professor, you would usually get graduate students or undergraduate students to do hundreds and hundreds of trials of these tests to ensure the accuracy and to prove your results. In this class, we'll do probably one, maybe two for each experiment just out of time constraints. But in the world of science, they do a lot of trials for each experiment. Once you've completed the experiment, the next step is to gather all your information and to organize it. And there's several ways that you can organize information. You can create data tables, you can draw graphs, and in this class we're going to do a lot of line graphs. And once you have all your information organized, you're going to actually analyze them by doing calculations, every once in a while some statistics. Once you've gathered all your information, organized it into tables and graphs, and done your calculations, the final step is to actually figure out what you can understand from this experiment. So you're going to draw conclusions and create a theory that will explain the results. And the final section for this one chapter is just to write down a few definitions. So first let's write down a hypothesis, since that is a word that you don't use in everyday life. We mentioned it before, but just to have it again, hypothesis is a testable prediction used to explain observations. And for this class, sometimes I'm going to ask you to write a hypothesis for your experiment, and if you have trouble writing one, a lot of times you can get away with doing an if-then statement. So if this, then this will happen. That's a good way to get started with a hypothesis if you're not sure what to write. And the last two words for this lesson tend to get really confusing for students, so make sure you can understand the difference between a law and a theory. A law is something that is a fact of nature that's observed so often that it becomes truth. A fact of nature that is observed so often it becomes truth. For example, if I hold a pencil up and I let it go, I know that it's going to fall to the floor because I've seen it happen so many times that I know it's going to be the truth. I know it's not going to hover in the air and sit there next to my fingers. I know it's going to hit the ground. Notice that it doesn't tell you why it's happening. So for scientific law, maybe next to that you might want to write the word what. It tells you what happens, but it doesn't tell you why. So the law would be that the pencil is going to drop. Another example is the sun will rise every morning. That's something that's happened so often we can predict that it's probably going to happen tomorrow. So the law is what happens. The theory is why it happens. So this is the explanation that explains why something in science happens. And it's based on observations and experiments. For example, when I'm dropping the pencil, the scientific law is that it's going to fall to the floor. The theory has to do with gravity, so the gravitational force of the Earth pulling the pencil toward it. Same thing with the sun. The sun rises because it's a heliocentric. Helio means sun, centric means centered. So we believe that it's a sun-centered solar system, and as the Earth rotates and revolves around the sun, it's going to change the seasons and change how the sun rises in the east every day. So theory answers the question why, and scientific law answers the question what. And that is all for this lesson. Hope you enjoyed it, and I'll see you next time.